Hey guys, welcome back. So, my previous stream I just binned it there because, just so you can see, there's the plug on this. This power supply appeared to be dead in the water, which is a pain in the arse. So I thought, I'll have a little poke around. In fact, tell you what I'll do, is I'll put my reading glasses on, then I can see what the hell I'm doing properly. I was trying to figure out why shit wasn't looking so good there. Oh, I can see for miles now. Right, okay. So I'll just get into the stream chat room. Why is it showing my status as being offline? No, it's online. Do I have to have Twitch running or something like that? How long have we been broadcasting for this session? I've got a follower. So I'm not sure why is this. There we go. What away again. Right, hopefully I'm in the right area on the creators. So just saying there, sorry if you've missed it. Was that this thing? This is for Commodore Amiga A500. And I thought, I know what, I shall sort it out, plug it in, no power, got a spare power supply, used that and there was power. Had a quick probe in the end with it plugged into the mains, which it isn't anymore. And nothing, there was no power coming out, so I thought, let's have a probe around, see what we can do. I actually went offline because I was going to go away and find a see if I find some drawing or some sort of thing to figure out what was going on. This is a pain in the backside with that camera being offset as far as it is. Need it moving round. Well, we'll get around to that. So anyway. So I thought, there we go. So we've got continuity one way, as you should have. And not the other way. No continuity, continuity. No continuity, no continuity. No continuity, no continuity. Two knackered diodes. Now if these two diodes are part of a full bridge rectifier, which looking at that, they are. So we've got them there. That's our bridge rectifier for the mains. However, it's on the high load side, so I wonder whether we're passing through AC. Well, can't be. So we've got bridge rectifier there. I would have thought we'd have AC going in and coming out with DC, so we've got our so coming out of these will be our +5, +12, -5 and +5 and ground. Big tracks on this side. This is the cold side, so you've got the hot side, cold side. Big tracks on the cold side because the ampage that's being produced. I think on this one it's about 4.5 amps on the 5 volt, 12 volt rail rather, which is quite a big chunk of ampage to be going through small tracks. So that's why these tracks are so big. Trouble with big tracks when you're trying to desolder stuff is that's a gigantic heatsink, so it's a bit of a mare. So yeah, so I suspect that both of these diodes are gone, knackered. I've got my little 60 watt soldering iron. 60 watt? I'm saying it's 60 watt. I think it's 60 watt soldering iron. But what I'm going to do now is I'm just going to see if I can just stick the fans on. I'm going to see if I can lift off where I can find them these two diodes, so it's these ones here. All I need to do is just take one end out. But as I say, I think I might struggle. Yeah, can you see that struggling there? I'm just not able to sink the heat in. Actually, that it did. You beauty. Yeah. Ho ho! Wasn't expecting that. So again, a little bit of nasty leaded solder in there. Perfect. So I'm just looking for a pair of anything really. Hopefully that's enough. There she goes. It's one out, or at least loose, that's all I want. And now we'll try and do the other one. There we go. So they're both loose. Double check the diodes. So yeah, that's definitely diode open circuit. Yeah, they're both diode open circuit. That's good news-ish. Means that I know what the problem is with the power supply. So what we'll do is we'll just give this a clean up. Tell you what, there you go. So I've just got my hand underneath. There we go. Both them out. Solder wick. You know what? Freaking looking for them. Wire cutters. Trim the wick down. And we'll clean this up a little bit. Doesn't clean up very nice. But it's clean enough. There we go. Clean and ready to rock and roll. Really pleased that I found what the problem is there. Now these are SPR50. Need to find some of them, I suppose. Don't need that screwdriver. Put that away there. Put that back in there. So these are SPR50. Now I've got some nice chunky diodes. DTSPR50. So a quick shuffle on tinterwebs and let's see if there's there's any way of stock some locally. So diode SPR50. I'm dyslexic, so if I do keep on repeating stuff, it's to help with that. So it's a 1000 volt 5 amp fast recovery diode. So if we have a look at the data sheet for that, we might be able to find something similar, which would be nice. Let's have a look. Right. I'll do a fair few TV repairs. SR5100, so SPR50. N-channel household MOSFETs. They lie like a cheap Japanese watch. So let's see if we can get some information. Data sheet. So reverse current 10 microamps, maximum forward voltage 1.7 volts, recovery time 70 nanoseconds, maximum forward peak surge is 200 amps. Now then, I have a sneaky suspicion UF51. So these are UF5402. UF5402. Yeah, see this. If I can find the data sheet. That's why it's not just sent me to freaking stupid thing. So 3 amps. So maximum forward current is 150 amps, but we're looking at 50 nanoseconds, full voltage 1 to 1.7. This will do it. Let's just be 100% sure. Actually, this is the so that's for the standard UF540X. The 5402 maximum DC blocking voltage 200 amps. Guess what, boys and girls? Fix it. That's after I've killed my laptop, maybe. Oh my god. Right. So that's quite handy. So I can replace those ones with an equivalent. So therefore I deserve a beer. That's nice stuff. Too nice. So we'll have the old doodah back on. Have a couple of these. I'm really pleased with that. So these pins are actually really thick, and I've done that a little bit, well, not close enough actually. So we'll move that a bit further out. Sorry, I'm not doing that. Does that look good, or does that look... That looks good. Perfect. Absolutely perfect. So we'll get this other one in, bent up and ready to go. Now what's going to be even better is if this goes horribly wrong and there's a gigantic bang. You know, that's always good for a laugh. Right. Soldering iron, solder, diodes. And then a bit of heat sink into that there. That'll do for me, you know. These are manky. There we go. I'll do. Just make sure it doesn't fall out. Oh, that fucker gets hot. I am sinking a lot of heat into these. But I really want these to go in well. There we go. Probably should have done that to begin with, just bend the legs slightly. But this, I mean, I guess when you think about it, you know, having the diode against the motherboard, or against the board, may not be the best thing because you're not going to get the heat dissipation around it. So I'll give that a couple of seconds to... Where's my bottle opener? There we go, that's cooled off a little bit. And there we go, that's that. So I think now so that's going to make a noise. You can see, yeah. We're in a good place. Well, okay, we're in a better place. So I'm just going to leave this in here loosely. This way it makes it so much more fun when things go bang, we all get to watch it together. Right. If I go offline, then it's my wife's going to be shouting at me. So I've got live at that end, so I need to be super duper careful. Yep, that's looking good. No bangs, pops, farts or sneezes. What I need now is to see if we can see some voltage at this end. Let's not have it on millivolts because it'll see a lot of them. So there we go, hopefully you can see that there. Yes, I can touch the shield and I'm not dying, so that means I've not got some dodgy bad earth going on there. And well, yeah, so that didn't go exactly how we planned there, did it, folks? So I'm wondering whether this needs some sort of feedback current. I'll have to go through and check even more, aren't I? Because that's a royal pit, and in fact, you know what? I can see another diode that doesn't look clever down there. Probably should have checked more when I was doing this, instead of just going and seeing them replace them ones. Yeah, I'm going to have to go through some more components. Arse. That is switched on. Yeah. Right. Not necessarily back to the drawing board. What am I going to do with this screwdriver? I'm sure you already know. But basically, these caps could well have a charge in them. And I don't want to get... Oh, they're alright, so there must be a discharge resistor across them somewhere. Just don't want to get a nip off them, so that's it, we're dead now. Make sure I've unplugged the right one. Yep, 100% unplugged. Alright, onwards and upwards. Sorry, excuse me. No idea. Right. So nothing there. There's another diode. Obviously it's another diode, but what's going on here? This got a shitload of naked diodes. This... Right, I'm going to lift another diode out. I wonder whether it's somehow it's blown the nuts off all its diodes. Never heard of that before. But just because you've never heard of something doesn't mean it can't happen. So that is a 470/16. I wonder if I've got any of them. If I've got some of them, I'll just lift that out. Also 1000 common intellis. Alas, no 470s. Well, I know it is a 470, but so that's actually a 470/16. Second hand. If I install that, am I putting in trouble? What else have I got over here? Sorry folks, just lean that back a bit. 1000 470/16 brand new. There we go. I thought I had some. Yeah. See, these are actually quite old. And what I used to do is, if I took some of the bits, I would save the components and reuse them. I've since learned it really is false economy. Yes, that's 470 UF 16 volts. 470 UF 16 volts. We'll get that replaced. taken out. It's probably some. These are just. Don't get me wrong. These are a no-name capacitor. And when I say no-name, I mean Chinese. So it's some dodgy Hoof-Lung Dong manufacturer. Right. So first things first. Let's lift a resistor. Let's lift that one there. So, as I've done always so far, just bung a bit of the good stuff in. And damn it. Come on. There you go, so that's that end out. Just making sure I got the polarity right, all the polarity is on the board. There we go, that's that out. Clean the holes up. Ooh, a big chunk of snot in there. So here's our suspect diode. Closed circuit, open circuit, closed circuit, open circuit, apologies. How weird is this? Right. I'm gonna guess this is a. I was going to say it's a 1N4007. So let's see. Diode. Now, if I don't have 1N4007s, there we go. There we go. So we'll just replace them all. None of this messing around. We'll just replace them all with new. Just makes no sense at all to mess around. And yes, you do need to have your tongue hanging out when you're doing these kind of things. Just nearly grabbed all that with my finger. That would have been fun. These things get so full of shit, it's incredible. Right. These will probably heat. That was a close one, just nearly cooked a finger. So that's them bad boys out of the way. We've got one down here. So that's him there to there. Again, pop him out. Oh, there's another one back there. Oh, you little mother. Right, that's that one. Just seen another one. Just here. And nearly done. Right. So those two are different to these ones. No problem. First things first, get the board cleaned. So got some nastiness going on there. Actually, tell you what, let's do it properly. So a little bit of flux. And get the tape on it. Somebody wants to get hold of me, they're going to have to wait. Yeah, these are clean up, gorgeous. It's a shame you can't see this. Thing of beauty, absolute thing of beauty. So as I say, only going to be doing these bottom ones. Tell you what, let's get this lead out of the way because it's getting right up my outer. And sit down there. Sit down there. Oh, that would have been fun if I had dropped them everywhere. See, there is definitely something, there's been an event in here. Because there's lots of, I'm not sure what it is actually, there's just something like a fine powder which is everywhere. I don't think it's that kind of powder. That's them done. So we shall trim that legs off. So we know this is, see I was saying that down the other end was bridge rectifier when we got the bridge rectifier at this end. So that doesn't make any sense really. So looking right, and that needs to clean. And I put, oh, there's my blue cloth. Don't need them. Those two are the ones that are goosed. Oh, not goosed rather. We'll just, once I've got this cleaned off, actually seems to have cleaned off when I'm about to change that capacitor as well. But if I change that capacitor, yeah, let's just change it. Let's get on. And it's them two pins there. And I've just dropped the cap. And just found some rubbish. There we go. So put the cap there. One last look, negative towards me. There. Big chunk of scabbiness there. So now just warm the leg up and first class words that will just pop out, but there it is. Give it a clean. Let's do it properly. That looks absolutely gorgeous. Negative towards me. Yeah, there's just some strange goop on this motherboard. Keep on calling it motherboard. That's because I've spent the last few days working on motherboards. Right. So it can only be getting better now, can't it? And I took the brush, cotton bud. Oh, actually, have I got? Looking for my component tester. There it is. Okay, so stop laughing. So we'll bang this on the old component tester and you'll see what it says about that. Right. $486 UF. 486 UF. That's not bad actually. 470, give or take 10%. So that's actually pretty good. ESR 1.4 ohms. Yeah, that's actually that capacitor is okay, but it won't harm. Bit of alcohol on there, and I melted my toothbrush earlier, so that's a little bit irritating. Clean out while we're in there. You can usually feel it when you've got a bit of flux, because obviously when you're using a toothbrush, all you're doing is moving the flux around, you're not actually lifting it off, whereas this does. But what the doing with the toothbrush does is it lifts it up and just makes it thinner. So now the board is squeaky clean down there. Right. As is always the case, once you start cleaning shit, you find crap everywhere, so you end up cleaning all over the place. There we go, that's that. Cleaner. And now, yeah, so yeah, that's exactly what's just happened there. I can goo all down that edge. I really should wear gloves when I'm doing this. Right, let's get some. So I need to find out if I've got an equivalent to them two there. Yeah, about as much use as I don't know what. Looks like it's just been chewed by a beaver. And we'll get this cleaned off. Got to be a better way of doing this. Right. So we're now looking for something that I can't read, so excuse me while I break out the gigantic magnifying glass of over the topliness. So these are FR10 FR107. Recognise that? I recognise that. So therefore, if I recognise it, I can have a slug of beer. Get rid of the old sword knife for now, I guess. Right. So if somebody else decides to join and wants to talk to me right now, tough. FR107. So if you're just joining the party now, why am I writing stuff down, repeating it? Because I'm dyslexic, and that is my way of actually remembering things. So it's a standard recovery diode. FR107, so it's 1000 volts, 700 RMS, DC blocking voltage of 1000 volt block, max peak, and RMS. Maximum forward rectified current 1 amp. Forward current. Peak surge current 30 amp peak surge for 8.3 milliseconds. Maximum instantaneous forward voltage at 1 amp is 1.3 volts. Okay. Maximum reverse current 5 microamps, and recovery, reverse current. That's wrong. I can't be. I'm misreading that. I've got to be misreading. Maximum DC reverse current at rated DC blocking voltage. Right, I see. Okay. So 5 microamps. Maximum reverse recovery FR107 is 500 nanoseconds. Okay, so that's going to be the fun bit. Right, into the what have we got here? No, I think on those I'm going to be screwed. So unfortunately I only do big beefy. Yeah, these are all huge chunky ones, so what kind of suck? Oh. Yeah. Those are all monsters. Moon stars. Us. What else? Yep, something else on the shopping list. FR107s. So that actually puts me at yeah, that's an arse that, so I can't do any more on that, and I've got another one there, FR107 there, so I'm gonna, yeah, I'll just get them replaced. Let's check, pardon me, FR107 on eBay. Really? Why is that on the eBay.com? .coco. Okay. FR107. Let's check that. Fast recovery diodes. Pack of a few. 100 assorted diodes. You know, that actually might be worthwhile. They come from the UK. Pack of 10 for £1.75. Pack of 50 for £1.10. That comes from Shenzhen. And those ones from the United States of America. Yeah, I'm tempted to go for these ones. The 5. You know what? Yeah. Oh wait. I want them quick, and 18p postage. See, this is the problem. It's if I want them within 2 or 3 weeks, then I've got to buy in the UK. In the UK, the people buy these from China, so I can get 100 for £1.80. China again, £1.31 for 100. 200 for £3.87. See. And in the UK, it's a couple of quid for 5 or 10. That's what the annoying thing is. I'll have to just buy it now because I want them. Right. Okay, well folks, you don't really want to sit and watch me do this while while I sit and wait for these to be delivered, really. So, on that note, I shall love you all, leave you all. I don't have anything in my shopping basket. Oh, that's fine. Yeah, that'll do. Yeah, so thank you all for watching, taking part, and yeah, I'm going to put this onto YouTube, so it's probably going to seem a bit weird, but yeah, this is going to go on YouTube, and take care, speak to you all soon.